Hey guys, here's this first problem. Please don't mind me while I hold the camera and talk into it. We have to solve these. These are inequalities in two variables. Look, I got an x and a y. So therefore, we're going to solve it by graphing and shading. So the first thing that I did when I did this problem is I found the vertex by using negative b over 2a. That's this step here. B is negative already, so negative 8 is positive 8 over 2a, so it's just 8 over 2, that's 4. Then we find the y-coordinate of the vertex by plugging it in. When you plug it in and do the math, that's what you get. You get 1. So the vertex is the point 1, 4. So I plot that. Sorry, I misspoke. 4, 1. So I plot that point, and then using the pattern, which is over 1, up 1, over 1, up 3, you know, the 1, 3, 5 thing. I'm going to do the same thing because A happens to be 1, so it's over 1, up 1, over 1, up 3. And then, of course, the mirror images. Parabola is dashed because it's just a less than, so on and so forth. Shading, my test point, my favorite number can be used, 0, 0. You see I did that over here. Plug in 0 here and here. We get 0 is less than 18, that's true, so we shade outside the parabola. The next one, for the other parabola, we've got negative b over 2a, so negative 6 over 2 times negative 1, the negatives cancel. We've got 3 for the x-coordinate. Plug that in, that's going to give us 2 for the y-coordinate. Plot that point, 3, 2. And then this time a is negative, so we're just going to go over 1, down 1, over 1, down 3. And it's solid because it is an or equals to. So then we shade, throw your test point in there, 0, 0. 0 is greater than negative 7. So where it's double shaded is outside the parabolas. Okay, the next problem was another inequality in two variables. So we've got y is less than or equal to negative x squared minus 4x. Okay, now when I graphed this one, I actually factored it. You can see I factored out the negative x, and I found the zeros. Well, with the zeros of negative, when I have factors of negative x and x plus 4, I knew that 0, 0 was one of my zeros, and the point negative 4, 0 was the other zero. And then I found out that, oh, by looking at it, I see negative 2. So negative 2 is my x-coordinate for my vertex, so I plugged that in. And I just did the math, and I found that I got 4 here. It opens downward because it's negative a. So I'm going to go over 1, down 1, over 1, down 3. Solid, because it's a less than or equal to. And then I can't use my favorite number as my test point, so I plugged in 1, 1. And when I plugged in 1, 1, I got 1 is less than or equal to negative 5, which is not true. So then I shade inside the parabola. Number 3, which I don't know which one it was on in your little scavenger hunt, but here's the problem. Okay, you start by moving the 72 over, factoring, and so on and so forth. We're solving it algebraically. Okay, at this point, once I had it factored, I'm like, okay, well, x is negative 8 or x is 9. Now I had to pick a test point, so I tested 0. So I plug in 0 here and 0 here. I get 0 is greater than 72. Well, that's not true, so therefore my solution set's going to be on either side of my boundary lines. So that's why I know x must be less than or equal to negative 8, or x is greater than or equal to 9. Okay, notice here there's only one variable. Okay, when you have an inequality in one variable, then it's just going to be a number line. Next one is graphing. The the vertex is 0, 0. This time a is 4, so instead of going over 1, up 1, I'm going to go over 1, up 4, and then the next one would be over 1, up 4 times 3, which would be 12, and obviously that's off my graph. So I only can plot those points, so that's how I did that. The next one, they're giving it in vertex form, so you plot the vertex, Happy birthday. The vertex is 2, negative 2, so plot that point. And then A is 1, so you got your little pattern. Over 1, up 1, over 1, up 3. Okay, next one. Identify the minimum, the maximum, the domain and range. Okay, well they're giving you the function in vertex form. So the vertex is the point 3, negative 3. It opens upward, so therefore it has a minimum value of negative 3. That's when y equals negative 3. Your domain is going to be all real numbers. Your range is going to be all real numbers where y is greater than or equal to negative 3. Number 7, or the next one I should say. Here they're giving you the graph. And you're going to write the equation. When you're given the graph, you're given the vertex and another point. So you're going to use vertex form, which is what I did. The vertex and another point. Okay? So starting with the vertex, I plugged it all in at once. I plugged in the point for x and y, and I plugged in the vertex and did the math. I got a is negative 1. So your equation is here. Okay. Number 8, this one's the next problem, is very similar. It's actually the same exact thing, vertex and a point. So that's how you do that again. The next one, more graphing. Graphing from standard form, okay, using negative b over 2a to find the x-coordinate of the vertex. Plug that in to get the y-coordinate of the vertex. And then use your pattern, over 1, up 1, over 1, up 3. Another one, graphing from standard form, negative b over 2a. Okay, the vertex is 1/2, and the y-coordinate's at 4.5. Plot that point, over 1, down 1, over 1, down 3. This one says to convert to vertex form. Okay. Well, you got a couple things you can do here. You were taught to complete the square. So that's what I did. I moved this 6 over. So that's why I got y plus 6 equals x squared plus 6x. Then in the process of completing the square, you're going to do b over 2, which is 3, squared, which is 9. You're going to add 9 to both sides. That changes it to y plus 15. Factor this, because it's a perfect square trinomial. Factors to x plus 3 squared. Move the 15 back over. The other way you could do it, you know a, okay? Remember, y equals a times x minus h squared plus k. If you can find the vertex, and you know a, because a is that variable right there, or not, it's not a variable in this case, but a is going to be that number right there, okay? If you can find the vertex, any way you know how to find the vertex, you can plug it in. Okay, my number 12 is the 3x3 system, and I'll show you that right now because I have it over here. Aren't I silly? Alright, you set it up by plugging in all your points into the equation. I simplified, I did it all at once, so you know you can do that sometimes. I got 20, 4a minus 2b plus c. We were given the y-intercept. Congratulations, that's a gift, okay? That's just like the example done in class. And then the other equation, I should say. Then plug in for c and make your other equations and go about and do the math. Okay? There is the final equation for that parabola. Okay, now the rest of this stuff, this is factoring. Okay, I shouldn't really need to explain factoring, This one I will explain, number 15, because I found another way to do this. It's kind of easy, especially when it comes to finding, when you multiply these two, you get 189. Well, to find the factors of 189 that'll add to 34, it took a little bit of work. So what I did is I did the prime factorization of it here. I got 3 times 63 is 189. I know 3 times 63 is 189, and why do I know that? Well, because those are the two numbers I multiplied to get the 189. Well, 63 is 3 times 21. 21 is 3 times 7. All right, then I'm looking at those numbers. So it's 3 times 3 times 3 times 7. Well, what is 3 times 3 times 3? Oh, that's 27. What's 27 and 7? There's my 34. Okay, so any combination of the prime factors, so I could have used 9 and 21. I tried that, 9 and 21. I'm like, no, that's 30. So then the next one would have been, logically, 27 times 7 to add up to 34. Okay, and then I did my little factoring trick. Okay, so my factors of 189 that'll add are 27 and 7, and divide it by 3x, because that's your first term over here. Simplify this fraction to 9 over x. This one does not simplify, and there's your binomials. We got x plus 9, okay, x plus 9, and 3x plus 7. Okay, this is the difference of two perfect squares. Then we get to solving. When we solve, this is where you factor and then set each factor equal to 0 for 17. This one's got such an easy method for solving. Get the x squared by itself and then just square root both sides. Here, you got a perfect square trinomial. So you can factor it to its perfect square and square root, or sometimes, if you subtract the 9 over, that would probably factor to 11 and 55, or 11 and 5, or something like that. Okay? Now, a big thing here is you have to do this math. I've had some people come and ask me questions. I'm like, well, what is positive 3 plus 8? And what is negative 3 plus 8? Okay, do that. Do the math. Okay? This problem, I had to use the quadratic to do. Okay, here I am. I divided by -1 first. It doesn't matter if you do that. You don't have to do that, but you can. If you don't, you're going to end up with a negative in the denominator, which you'll have to just know to move it to the numerator. Okay. Next one, simplify. Well, remember, the negative underneath the square root pokes an I out, so we've got I times square root of 96. Well, 96 is 16 times 6. Square root of 16 is 4. Simplify here. This is a subtraction problem, people. So it's 5 minus 6, which is -1, and 4i minus I, which is 3i. This one is multiplication. You got a binomial next to a binomial, so you FOIL. When I FOILed, I got negative times a negative is positive 24, then -8, then positive 30, and then it was originally negative 10i squared, but the I squared changes the sign, so it makes it positive 10 here. Then you just add the combine your like terms. Next one, you have to multiply by the conjugate of the denominator. Okay, conjugate pair of the denominator. On the top, we're going to get the 18i squared. It's minus originally, but the I squared changes that sign. Likewise here, your shortcut's going to be 25, and it's going to be plus 9. And then you're just adding and simplifying. And then the last problem, use the quadratic and solve.